We are going to start by reviewing the complete balance and net ionic equation that you will need to know how to do for your test Friday. It is very important. It's a big part of our set unit because we did it in the lab. We've done it in assignments and QCs. It's going to be a large portion of your test. You need to know how to write equations and make net ionic equations from those balanced equations. So we are going to do that process again as a review for your test Friday, and then we're going to move into new material over solution. Okay. So I have my wheel up and I'm going to be calling on people per usual. So be ready. All right. Okay. Dun, 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 dun. First up, the question is, write the complete balanced and net ionic equation for strontium bromide and potassium sulfate. So Akshar, you were called on first on the magical wheel. Akshar, are you here today?
Yes.
Awesome. Good morning, friend.
Good morning.
So before we figure out what the complete balanced equation is, we have to know whether these compounds that we are given are reactants or products. What do you think?
Reactants.
Yes. Why do you think they're reactants?
Because we're trying to figure out for these two. So
Yes, and it doesn't say we're creating these two. It says we're doing it for these two. So if we were creating or producing it, these would be our products. But since we don't see those keywords, we know these are our reactants. Awesome sauce. You did amazing. All right, Maheen, you're up next. Strontium bromide. Okay, we need to make that from words into chemical formula. So strontium bromide is what type of compound? Ionic or covalent? Is your mic working today, Maheen? I know you're here because I saw you in the chat.
Ionic.
There we go. It's ionic. How did you know?
Because metal and non-metal.
Yes, it's a metal and a non-metal, so it is ionic. So we're going to do it based on charges. So what charge will strontium have? What symbol and charge? Oh. What symbol and charge?
Strontium is 2+. And
Yes.
then the symbol, like, oh,
yeah. So what I was going to show you guys is that a lot of elements are in here. So if I were just to type in strontium, you see how I have strontium, and I know that's SR. That will help me on the oxidation chart, that if you don't know the charge for something, you can go use, sorry, I scrolled the wrong way. Here. So you said it was 2+ accurately. If you did not know it was 2+, you could have gone here to see that is in group 2 and therefore 2+ right here. Awesome. Yes, that's what I was asking. What about bromide? What's the charge for bromide? Oh, sorry, I forgot to call on someone. Maheen, you did great. Thank you so much, doll. All right. Corey, bromide, do bromide for me.
Okay, 1 second. I'm getting my reference packet.
Yay! Those are my favorite things that you guys say to me. It's my favorite things.
Okay, so bromide has a charge of -1.
Yes, and if you did not have your reference packet and you just had a periodic table, you would know that because it's group 17, so it gains 1 electron. Awesome. So next up, thank you so much, Corey. And thank you for using your reference packet. Victoria, C. How do these combine to make a molecule?
I'm not completely sure. Can you help me?
Absolutely. I would love to help you. It means I get paid. Thank you so much. So strontium is 2 positives. That means it lost 2 electrons. Bromine is 1 negative. It means it gained 1 electron. So there's 1 electron we lost that has no home right now. So we have to have enough bromine ions to have a home for every electron that was lost from strontium. So how many bromines do I need?
Just you need 2.
Yes, I need 2 Br1 minuses. So what that means is when I write this as a molecule, I'm going to write it as SrBr2 because I have 1 strontium and 2 bromines to make that add up to 0. Positive 2, negative 2, 0. Last question for you, Victoria. If using this solubility chart that I'm going to put up here for you. Dun, 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 dun. Slowly, slowly, slowly. There it is. Strontium bromide, which is SrBr2. Is it aqueous or is it solid?
It is. Hold on. It's aqueous.
Yes, it is. How did you know? Which rule?
I kind of guessed because like the chart thing had bromine in it, or like the sign.
Yeah, so
Yeah.
we use 2 of those, right? That's what we wrote twice to balance it out. So it's this salt and it's aqueous unless, you know, very Lorax, unless it's bound to these. We are not bound to silver. We are not bound to mercury. We're not bound to mercury 1 and we're not bound to lead. So therefore, this must be aqueous. Good job, Victoria. You did a good job. So this is AQ. Awesome. All right, next up. Jimin, can you start potassium sulfate for me?
Potassium sulfate.
So what's potassium going to be?
K.
Yes, and what charge is going to be on that K? Scrolling, flipping. Here we go, right here.
+1.
Yes, +1. It's also in group 1. We know it's 1 plus. Yep, you're good. You're fine. It's my job. You good. All right, that's awesome. So I'm gonna have someone else do sulfate. Sonali, what does sulfate look like?
Is it SO4?
And what's the charge on that? I hate when it does. What's the charge on that?
2-.
Yes, it is 2-. Where can you look that up if you don't know?
The reference packet.
The reference packet. Oh, I'm going to mention it so many times. It's going to be so annoying. It's so great. Shanmati, you're up next. How many of each ion do I need to make them add to 0?
You would need 2 potassiums and 1 sulfate.
Yes, so I would write that. Oop, hold on. I did not leave room. I would need K2SO4. Now we're not writing the parentheses because there's only one of them. But if there were 2 or 3 or 4, we would put parentheses around this whole thing because they're super glued together. They never get separated. And we would put the subscript after the parentheses, just as a reminder. You did great. Thank you, Shanmati. All right. Magana, what phase state is this? Solid or aqueous?
Aqueous,
Yes. How did you know?
because all SO4s are aqueous except for some stuff, and potassium isn't one of the exceptions.
Yes. There's also another rule that says group 1 salts are aqueous without exception, and potassium is group 1, right? So both of those rules are telling us the same thing. You did great, Magana. Look at you guys. You're killing it. Do you remember how much we struggled with this in the beginning? Do you hear how awesome you guys are doing? Like all of you? That is so amazing. You guys are doing great. All right, Sneha, you're up next. We have our reactants. We have our big arrow. What do we need to do now?
We have to write the reactants and balance the equation.
Yeah, we have the reactants, so we need to write the products. I'm assuming you meant products.
Yes.
Awesome. So how would I start doing that? What type of reaction is this?
This is a double replacement reaction.
Yes. How did you know?
Because of the reactants.
There's how many types of ions?
2. Or 4, sorry.
compounds made up of 1, 2, 3, 4 types of ions. Okay, so when we're doing double replacement, we're replacing 2 things. We're replacing the negatives with each other. So bromine leaves and displaces sulfate. Sulfate leaves and displaces bromine. That's where the double comes from. 2 things are moving into a new compound. Awesome. So, Sia G, SIA, what would be my first product? Which one do you want to do first?
So I put the SR with the SO4.
Yes, and I hear that you said one of each. Why did you decide that?
Because I remembered for double replacement, they like switch partners, so I just like switch them.
Yes, in their charges, do they add up to 0?
Yes, they do.
Yes, because SR is, I got to keep this consistent or it's not going to make sense. SR is 2 plus, SO4 is 2 minus, those already add to 0. What phase is this?
This is a solid.
Yes, why is it a solid? This sulfate was an aqueous. Why is this one a solid?
Because on the chart, it says that all salts of SO4 are aqueous, but the strontium is an exception, so it's a solid.
Yes, strontium is the exception on sulfate, so it's a solid. That was perfectly done. You want to teach class next time? That was so beautiful. You can say that all the time to all the classes. Charles, you're up next, friend. We've used strontium, we've used sulfate, so what is my other compound? Charles, are you here today? There you are.
Would it be potassium?
Potassium would be one of them. What would be the other one?
Bromide.
Yes, bromide. I love that you said bromide, not bromine. Perfect. And do they stay in a 1-to-1 ratio? Or do we need more of one than the other? How many of each one do we need?
I'm not really sure.
Okay, so potassium is 1 plus and bromine is 1 minus. Do they add to 0?
Yes.
Awesome. So if they add to 0, we only need one of each. Last question for you. Is this aqueous or solid?
Would it be solid?
So this one's already solid. So usually there's only one precipitate, not always, but K is a group 1. This is group 1. Okay. And there's a rule that says all group 1 salts are aqueous with no exceptions. Okay. That's the first rule on your paper. So this one's actually going to be aqueous. There's another rule about bromine where there's a few exceptions and potassium is not an exception. So there's 2 different rules that tell us that this is aqueous. Okay. All right. Thank you, Charles. Dia, we have an equation. What do we got to do with it now? What do we do with every equation we're given?
We have to balance it.
We have to balance it. Can you balance it for me?
So there's 1 strontium on the reactants and there's also 1 on the product side. And then there's 2 bromine on the reactants and we need 2 on the product side. So we'll add a 2 in front of it.
There's BR2 here and there's BR1 there. So we added the 2 and then that here, right?
Yeah. So we already have potassium's already balanced and then SO4 is already balanced.
Yep. So now this is the balanced equation. Love it. So this is the first half. Completed balanced equation. Give me a scale of 1 to 10 of doing this half. Scale of 1 to 10 before we go on. Okay, this should feel like breathing at some point. If it's not exactly breathing, but at least now we know that if we think about it, it happens for us. That's a good thing. We're hoping to be between an 8 and a 10 right now. If you are not between an 8 and a 10, that is okay. It is valid, and I want you to tell me. But that also means you need to be seeking to understand and being an active participant in your learning, which means go to tutoring, participate, ask for help, please. Okay, or book with me. If you don't want to see another teacher and you think they're scary, tell me when you're available first or eighth period for an async and I would be happy to meet with you. Okay, but you have to be at least an 8 right now on this. And if you're not, you need to actively participate in your learning. Okay. Self-advocacy, it's cool. It's a grown-up thing. We're doing it. We're doing the thing. All right, next up, Victoria V. We need to build the net ionic equation. How do we do that?
You break apart your products and reactant side. But wait, first you have to find the I forgot the word for it. I know it's strontium sulfate.
Yes, it's this little letter. So if it's not aqueous, you do not touch it. So this guy is solid. We do not break them up because the only reason we're breaking things up is we're showing that aqueous means dissolved ion. Remember, those dissolved ions are in pockets of water with either the oxygens holding the positive or the hydrogens holding the negative and holding them physically apart like they wanted to do to Romeo and Juliet, right? They're still there, the attraction's still there, but they are physically separated, and then that ends in tragedy. And they were only 14 and it's a terrible story, just a personal opinion. But that being said, they're being held apart, okay? If they're not being held apart, then we are not going to separate them. We're only giving a mathematical representation of what's actually happening in the solution, okay? So we're going to separate them. Next question, Victoria, that was perfect. And you acknowledged the aqueous in the solid difference, and I loved it. Wajiha, you're up. When I'm separating them, what am I separating them into?
Ions.
The ions, I'm asking you for a specific reason. There has been a trend I have been seeing growing that I am not a fan of, okay? You guys are putting BR2 like this as a BR2. So I wrote this differently today on purpose, okay? The reason I wrote it differently is to reinforce the fact that this is not a BR2 gas, because I've been seeing this a lot, because we talked about diatomics and then everybody just assumed everything was diatomic. Diatomic is only for atoms. Diatomic. These are not atoms. Wajiha, what did you say they are?
Ions.
They're ions. They're not atoms. When we see BR2, it's only because we had 2 physical BR minuses that we are accounting for. So when I separate them, my first one would be that strontium 2 plus aqueous. They're the exact same as the ions we made to create the equation in the first place, right? For the bromine, and I'm doing this one for you so that way everybody is paying attention right now, because I do not want to see this on your test on Friday, okay? Is that there are 2 BR1 minuses that are aqueous because we physically had to add 2 to give every electron a home. Not because we have BR2 gas. Scale of 1 to 10, acknowledge me, say something, tell me if, I don't know, just acknowledge you're hearing me right now, because I do not want you to do this on this test. Okay? Acknowledge me, give me attention. I would love to explain it again. Okay, so when we're separating aqueous things, we're separating them into the ions that were used to make the compound in the first place. So for strontium bromide, we had 1 strontium 2 plus and 2 bromine 1 minuses. I've been seeing people put a 2 here. That is not correct. We have a 2 here only because there are 1, 2 ions here. So unless you have something that is not aqueous, okay, once it says aqueous, you are not allowed to do a diatomics. Does that make more sense? Because it's dissolved in part of a salt. It's not by itself, it's dissolved. Does that help explain? For those of you, there was actually 2 of you that asked me to explain. We're just separating them into what we used in the first place. I'm actually gonna write that closer because I see this. I'm gonna try to fit it all in one line, guys. We're gonna see. 2, why is that a different red? Would that bother anyone else? That bothers me. I'm so OCD, I'm so sorry. Hold on. 2 BR1 minus aqueous. Awesome. So let's separate the other one. Minahil, will you separate the next one for me? Potassium sulfate. What would I write?
So first you would write 2K.
What else do I need with that K?
Aqueous.
Aqueous, and what else? It's an ion. What's on every ion? What do we write up here?
Oh, +1 charge.
Yep, the charge. You could write just a positive sign, but I'm writing the one physically to drive a point home so you guys know what I'm talking about, okay? All right, and then what would be the next thing I write? I will call on someone else because there's so many of you guys. I need to get through everyone. Jonavi, okay? What would I write next?
SO4 2- aqueous.
Yes, you said all the parts. Oh my goodness, that made my heart so happy. Oh, you did so great. Thank you for saying the charge and the phase. That was beautiful. Carter, what do I write next? I'm writing this as a big yellow arrow so we notice that we're on the product side now. What do I write now? What's the next one?
Strontium sulfate.
Yes, you keep it exactly the same. You did not fall for the trap. Why do we keep it exactly the same?
Because it's a solid, not aqueous.
It's a solid, not aqueous, so it's not doing anything. So we keep it exactly the same. Love it. You're doing great and you caught it. I can't trick any of you guys in here. You're doing fabulous. All right. Next up, Eden. What do I write next?
You'd write down 2K 1 plus aqueous.
Yes. Oh, everybody's doing everything now. It's so great. Oh, it's so great. I love it so much. Love it more than I can say. All right. And then what do I put last? Samir, you're up, man.
What was the question?
What do I put last? We have one thing left to go. Finish it for me.
Oh, you have to put bromide. But it has to be balanced, so it has to be 2 bromide, 1- aqueous because it's dissolved.
Yes. Good. Hold on. I totally wrote that really poorly and I want to make sure it's neat. So if you guys are taking screenshots, it's a nice screenshot of notes. That makes sense. Okay. 2Br minus aqueous. I fit the whole thing. Oh, victory of the day. Okay. Sorry. It's so long. It's so hard to fit those on PowerPoint. Okay. So Esty, my love, what do I do now to get the net ionic reaction? The net ionic equation. What do I need to do now?
Don't you eliminate the bystanders?
Bystanders, I love to use that word because it's a perfect synonym for spectator. Yes, we've got to eliminate the spectators, the bystanders, whatever helps you think of it, but we eliminate them. How do we identify what those spectators are? How do we see what's a spectator or bystander? I like the word bystander. Spectator is the science word, but bystander is fun. I love that you said that.
You have to see what's on both sides of the equation. Yes. Like, for example, 2Br, and they're both aqueous, so those would be bystanders.
You even mentioned the phase. It's not even my birthday. You guys are making me so happy. Yes, 2Br minus aqueous, 2Br minus aqueous, the same for K plus. So our spectators, our spectator ions are ions that showed up to the equation and left the equation exactly the same. They were there, but they didn't participate. So it is Br minus and K plus as our spectators. Awesome. So last, but definitely not least for this section, Sangeet, tell me what my net ionic equation is. What's left over? What I got?
You get SR2 plus aqueous.
Yes, we add this down here.
And then SO4 2- aqueous.
Awesome.
Yields SO4 solid.
Yields SO4 solid. Yes, and we see that everything changed. Nothing is the same. So the net ionic, those are our players. We found our bystander spectator people, and we are good to go. Give me scale of 1 to 10 of how we feel on this. Again, this is a big portion of your test, so be honest. If you are not an 8 or a 9 or a 10 right now, you need to be. So that means you need to be actively participating in your learning by sending me an email this very second saying, I need help. Okay? You don't have to tell everyone, don't whatever, but stop this second and send me an email and ask for help, because you have to know how to do this and you need to feel like an 8, and you need to be able to be comfortable being honest with yourself and with me with what you do and don't know. It is my job. There is no shame. If you feel like you're behind, you're not. Okay? This is a difficult concept that usually takes kids a few weeks to get. And especially if you've been quarantining or in and out or not at your home, okay? There are things that you need to make sure you understand, and that's all I'm saying. Okay, well, the ions on either side of the equation never be crossed out. So if it's present on both sides exactly the same way with phase and charge, it will always be crossed out. But say in this example, we had Br1 minus aqueous and we had a Br2 gas. Those would not cancel each other out because they are not the same, even though they both have a Br in it. Everything about them in between the plus signs has to be the same. If nothing cancels out, then there is no net ionic equation and there's no precipitate form. It's not doing anything really. You're making 2 aqueous products from 2 aqueous reactants. So there wouldn't be a net ionic equation in that case. Everyone showed up and is kind of the same. It's just they're switching partners and whatever. Okay, we're not going to give you examples like that. That's the thing. If everything crosses out, it isn't a chemical reaction because nothing changed, right? Okay. Yeah, net ionic equations will always have ions that turn into a solid. Otherwise, it would have been crossed out. Yes, you will always have a solid product in these net ionics. So you should check your solubility rules. If you get everything aqueous or everything solid, it's like, yeah, I don't know. It's not a good thing. You need to check your work. That will happen, don't get me wrong, in real life, but like it won't happen on a test because that's not what we're asking you for, I think. I will go back and check because Haradem is a funny man, but we will see. Okay. I love the questions I'm getting though. You guys are so fabulous at asking questions. That's why I like recording this class. You guys are so great. Okay, so we are going to move to the next thing. So speak now or forever hold your peace. If you have a question, I'm going to give you about 10 seconds to transition your brains. We're moving into what your video notes were over that you were supposed to do before this class. So you will need your solubility chart in front of your face. You will need your unit 7 notes in front of your face in the solution section. So take a second to get those now while I wait for any last questions. And we're going to get the whole wheel plus some. It's going to be fun. Okay, moving on. Bum, ba, da, bum. So what are the 3 types of solutions? Saline. And if you don't know, don't Google, because everyone who's Googled has given me the biology answer, not the chemistry answer. We're not talking hypo, hyper, isotonic, although those are solution types. That's not what we're talking about here. 3 types of solution chemistry.
I actually don't know.
That's okay. I'm going to give you one of them. One of them is saturated. Can you figure out the other 2?
Disaturated?
So it's not 2, it's either going to be below saturation or above saturation. So there's prefixes to help you do that. So I will let you phone a friend. So you can call someone out by name on the chat to say it for, or on the video to say it for you, and then you'll say it again. And phone a friend. Call someone out. Who?
Maddie.
Maddie! You've been called out.
Yes.
What are the 3 types of solutions?
Unsaturated, supersaturated, and saturated.
Yes, perfect, love it. So Celine, what were they?
Unsaturated, saturated, and supersaturated.
Boom goes the dynamite. You guys did amazing. So,
thank you.
Good job. Teamwork makes the dream work. All right. So we have 3 types of solutions that are changing based on the concentration. Okay, as the concentration increases, different things happen. So first we have unsaturated. That means that Actually, I don't want to tell you what it means. I want you guys to tell me what it means. What am I doing? I don't tell you guys things. You tell me things. Okay. You sent me a lovely email. I did get it, and I'm not going to call on you right now because of it. Renee, what
Yes,
does an unsaturated solution mean?
It means it contains less than the maximum amount of dissolved solute.
Yes. So that was lovely, lovely, lovely academic vocabulary you used. I'm going to break it down a little bit. I always want you guys to use the vocabulary if you know it, but if you guys are not tracking on the vocab, basically what she's saying is that there's still room for things to dissolve, right? Solute is what is dissolving. It's the salt or the sugar or whatever you're adding to the water, right? The water in this case would be the solvent. It's what's doing the dissolving. Okay, so the solvent is going to be the liquid. The solute is going to be the not liquid that you are dissolving into there. Okay, so there is still room for things to dissolve, or it has not reached the maximum amount of solute in its solution yet. Saturated solution, love that, Renee, that was beautiful. Milan, what's saturated mean then?
It contains a maximum amount of dissolved solute.
Yes, contains the maximum amount of dissolved solute. So if extra solute shows up, what happens to it? Say I add more than can be dissolved.
It adds more than it can be dissolved.
Yeah, so what happens to the extra?
It's left over.
Yes, it's left over. If you've ever watched a 6-year-old make Kool-Aid, you've seen this, because my daughter doesn't do the 1 scoop. We've talked about this, right? She doesn't do the 1 scoop like it says. She just dumps the whole container in there, and then it becomes a sludge because not all the sugar can dissolve. So that leftover is because it's fully saturated. Everything has dissolved that can dissolve, and there's some left over, right? So you get that in the bottom. Also, when my son makes Nesquik, this happens. He likes to put the whole thing in there, and then it's just like chocolate gross. It's so gross. I don't even know. The texture is disgusting, but it's because not everything can dissolve, right? So I don't let them make it. So saturated means everything that has dissolved can dissolve. And if I add any more to it, it will not dissolve. It's just going to fall to the bottom and be whatever it is, depending on what I'm adding. Awesome. Super saturated. What does that mean? Kiera, what does that mean?
It means that it contains more dissolved solute than a saturated solution.
Yeah, it does. It dissolves more than it's supposed to be allowed to do. Okay. So I would hazard a guess that every single one of you has eaten supersaturated before, eaten something that was a result of a supersaturated solution. You probably did it in elementary school. You probably put it in a jar and you probably left it for a couple weeks and then you ate it. Does anyone know what I'm talking about? Oh, Shanmati, I saw you unmuted, but I think you talked before your mic was ready.
Is it rock candy?
It is rock candy. You guys all did this. You heated up water. So you dissolved all the sugar you could. It didn't dissolve anymore. So you heated it up, which made the water molecules move around a lot faster, which allowed them to dissolve more things because they're moving more. And then you slowly cooled it down. So that way that stayed dissolved when it shouldn't have. It was like, I'm going to give you an analogy here in a second. Then when you put the string covered in sugar in it, the extra sugar, it's not stable. So it's like, I'm going to hit you right out as soon as I can. And it nucleates. That's what that's called on the string. And then you eat it because it's pure sugar that's just renucleated in colored water. So yeah, that's what supersaturated solutions are. Also, who has drank sweet tea before? This is Texas. When I got to Texas and you tried to give me sweet tea, you as in the people of Texas, I nearly vomited. It was like syrup. I have no idea how you guys drink that. It is so sweet. It makes my whole face hurt. Like I do not know, like as a Yankee person, like that's something I've never, ever gotten on board with. It is disgusting. It is so sweet, but it's because you guys heat it up so you can dissolve all the sugar while it's hot. And then you're literally drinking syrup. It's ridiculous, but personal opinion, but sweet tea is also super saturated. If you were to put a string of sugar into the sweet tea, it would nucleate like sweet tea rock candy. It would be the same thing. It would be disgusting, but it would happen. Okay. So that's where we're at. So I'm going to give you an analogy. You have a hotel. Okay. You have a hotel. So you guys are going to create this analogy for me. Solutions are like hotels. Kai, if I have an unsaturated solution, what does my hotel look like?
Is it that like the hotel only has like a few rooms booked up?
Yeah, a few rooms are booked, right? A few rooms are booked, but there's rooms left over, right? So there are some empty rooms. So say you were to show up, say Kai shows up at the hotel and says, hey, I need a room for the night. They'd be like, awesome, we definitely have rooms available. And they would book her, right? So that would be an unsaturated solution. There's still room to book ions into the water hotel, right? There's still room for them to dissolve. And I'm going to tell you why I picked this analogy specifically here in a second. Evangelina, what would a saturated solution be?
It's a solution that it contains the maximum amount of dissolved solute for a given amount of salt.
What would that be in our hotel analogy? So if unsaturated has rooms left over and only a few rooms are booked, what are saturated?
Would have an equal amount of rooms booked and rooms left over.
So not that there's an equal amount, right? So saturated means nothing else can dissolve. We are fully booked. So what does that look like in the hotel?
A fully booked hotel.
Yeah, every room is booked. If extra people show up, where do they, what happens? Say you were to show up at a hotel and they're like, sorry, every room is booked. What would you do?
I don't know.
Okay, so say it shows up, right? And it's booked. You would have to figure out a new place to go. So you would hang out in the lobby until you used your phone or internet or whatever to find a new place to go. So every room is booked and extra people are stuck in the lobby, right? They're not going to let them up into the hotel because then people are going to sneak into rooms and stay for free. That's not cool. So extra people are stuck in the lobby. All right. So next up, Darshan, what would a supersaturated look like? Supersaturated hotel. This is the toughest one, just to be clear.
So I know that, so scientifically it's you boil the solution and then cool it down. So in the hotel,
because that allows you to do what with the sugar or the salt or whatever it is?
Dissolve more of the solute.
Then
right?
should be allowed, right? So what's that in our hotel analogy?
All the rooms in the hotel are filled out, so, and there are extra people, so they build more rooms, maybe?
Not that they build more rooms, but rooms are filled with more people than should be in there, with more people than allowed. This would be like if let me guess, if like say Charles had a hotel room, and my guess is if he was the only one in there, he would try to sneak Samir and Lucas and Bob and everybody else in there to hang with him, even though they didn't pay. So now there's more people in that room than should be allowed in that room. Does that make sense? So there's more people in the hotel than should be allowed. So here's the next question. Yes, I called you guys out and it's totally fine. So Izzy, when those extra people leave in the morning, do they want to leave when the hotel lobby is empty and like the attendant is staring at them?
Probably not.
No, what would be the smart move there? Smart. I'm gonna say you should not be doing this, but what would be the smart move there to not get caught?
When no one's looking, just get out of there.
When no one's looking, or when what else happens?
I don't know.
When there's crowds of people, like you can sneak
out.
Oh,
yeah.
Ever were like James Bond is running through the street and then there's a crowd and he like ducks into the crowd and puts on a hat and puts his jacket up and then like, where'd he go? Right? He would cop out with the crowd. So supersaturated solutions do that too. That's why crystals form. That's why rock candy forms. The sugar that's extra is unstable. It does not want to, it's not supposed to be there. Scientifically, physically, it's not supposed to be there. So as soon as there's a crowd, AKA a string with sugar molecules on it, that's disturbing it, it will hitch a ride out and leave only what's supposed to be there left. So that's why supersaturated will create crystals and you'll actually end up with more than you added in there And we'll see what that looks like in a second. But that's why I use the hotel analogy. Now, why did I use the hotel analogy? Because it's true. Water is a hotel. What did I tell you about how things dissolve? Tell me how tell me how a K plus ion dissolves in water. What does it look like? What does water do around it?
I'm not really sure.
So if I drew a water molecule, why do I draw the oxygen next to the K plus? So what we did last time. So if you're talking, I see you're lit up green. I can't hear you though. So I don't know if the mic is, there you go.
Because the charges are like different.
Yes, the negative positive. So oxygen literally surrounds potassium. The oxygen are the walls of the hotel room. Okay. If I had a chlorine, the hydrogens would be the walls of the hotel room. So literal ions are booked into rooms just like that. Water forms walls or bubbles, three-dimensional bubbles, floor, ceiling, and walls in a circular fashion, like circular rooms that isolate them from each other. Just like I said, like Romeo and Juliet in the beginning. They're isolated. So there's literally walls. And if there's no more room, or if water has been fully booked, if every water molecule is interacting with an ion, nothing else will be able to dissolve. And only when those water molecules are moving super fast, as in when they're heated up, will they be able to dissolve more than they should, because those walls are moving so fast, they kind of create these faux bigger rooms. And as they cool, it's unstable, but they kind of chill there until they can hitch a ride out, and then it forms the room again. That's literally what's happening on the atomic level. There is a water hotel and solute is booked into it based on the oxygen and hydrogen available. It's literally the exact same. Scale of 1 to 10. How we doing? It's a weird concept, but y'all are getting it. So anyone have any questions? I'm opening the floor for anything on saturated, unsaturated, supersaturated. We're about to do we're about to see how much you understand, but I want to make sure if you have any questions, they're answered right now. Okay. So next up, what I have here are beakers. Okay. So the beaker beforehand. Okay. So when you look at a solution of salt in water or anything uncolored in water, there's no way to tell how much is dissolved in it. This is why I used to do to my brothers when they annoyed me, because I had 5 brothers and they were physically bigger than me and they could beat the crap out of me. So I couldn't actually physically do anything to them when they hurt me. So instead, when they weren't looking, I would take salt and put it in their water and stir it up. So that way, when they took a drink, it tasted like butt, like it would tasted awful. So that was the way I got back at people, because, you know, it's fun. But the idea is, when you look at a glass of water and salt, you have no way to tell how much is in there. There could be no salt in there. There could be a completely saturated salt in there. You can't tell by looking. So the way you tell is by adding more solute, salt, sugar, whatever. And when it dissolves, or if it dissolves, will tell you if it's saturated or unsaturated. So this is a solution, and there's 10 grams of salt in a spoon. Okay. At the end of it, after we dump the salt in, there's 3.5 grams of salt in the bottom. So I want to know what type of solution was in the glass before I added the salt and after. So Lucas, you're up first. What type of solution is it in the beginning before I add the salt? And how do you know? Lucas.
Sorry, my parents were calling me. I'm back. What was the question?
So I'm asking, okay, so this is the beaker before we add a spoonful of salt. There's 10 grams of salt in the spoon. And after we add the salt and stir it around, there's 3.5 grams of salt left in the bottom, left over. So before we added the salt, was it unsaturated, saturated, or supersaturated?
Unsaturated.
Yes. How did you know?
Because it's just water, there's no salt.
Well, we don't know for sure there's no salt, but what happened? We went from 10 grams to 3.5 grams of salt.
The salt dissolved.
Yeah, it dissolved 6.5 grams of salt, right? There's 6.5 grams that were there that are not there anymore. I mean, technically they're in the water, but they're dissolved in the water. So the unsaturated dissolved is because it dissolved some salt. If it was able to dissolve, it means it wasn't fully booked. Just like if we show up to a hotel and we both get booked in a room, like I get a room and you get a room, we would know that the hotel wasn't fully booked because there was an empty room for me to go in. Does that make sense?
Yeah, that makes sense.
So it was unsaturated. Awesome. Thank you, Lucas. Next, Adhish. What is it after? There's 3.5 grams in the bottom of the beaker. So what type of solution is it now?
Is it saturated?
It is saturated. How'd you know?
Because there isn't more than what we started from.
Yeah, there's solute left over, right? If every gram of salt had a room, there wouldn't be any salt in the bottom, but there is salt left over. So 6.5 grams of that dissolved and 3.5 grams of it didn't have room to dissolve. The hotel became fully booked after 6.5 grams. Does that make sense? So if there's solute left over and it's less than what you started with, it means something dissolved and therefore it's now saturated. Nothing else can dissolve. Perfect. Good job. All right, same thing for this next one. Audrey, you're up. Audrey, in the beginning, there's 10 grams of salt above the beaker, not added yet. After I add it in, there's no salt left over. So what type of solution did I start with?
Unsaturated,
Yes, how did you know?
because there's nothing in it.
Yeah, so it had to have dissolved, right?
Yeah.
It dissolved the solute. So that means that there had to be rooms for open at the beginning. Therefore, it had to be unsaturated to start with. Okay, lovely. Next one, and this is trickier than it looks, so I'm giving you a heads up. Trisha, there are 0 grams of salt left over. So what do you think this solution is? After we mix it all up, all of the salt dissolved. So what type of solution is this?
I think it's saturated, but I don't know.
Okay, so the reason this is hard is because there are 2 answers. It's either saturated or unsaturated. It's impossible for us to tell. So you did good. You guessed half it. I'm going to ask someone else the why. Jessica, why did I say there's 2 options here?
Because like you said before, we can't tell if there's any more rooms left behind. So the only way to know would be to add more and see if there was something at the bottom.
Yes. Either this is unsaturated and there are more rooms left. There is more room for solute to dissolve. We have not reached the maximum yet. Or it is perfectly saturated. And if we add even a part of a gram, it's going to fall to the bottom. But there's no way for us to know until we add more solute. So this is either saturated perfectly or unsaturated. It's most likely unsaturated. It's very hard to perfectly saturate something unless you did a lot of math. So it's most likely unsaturated, but there is the possibility that the last gram of salt was the last room available in the water and therefore is now perfectly saturated. It is not super saturated here because super saturated means there'd be more dissolved than possible and something else would happen, which we will talk about here in the next problems. Scale of 1 to 10 so far. We're going to discuss supersaturated here in a second. Okay. You have to put both, Milan. You have to put both. It could be saturated or unsaturated. There are 2 options. You must put both. This on a test would be a checkbox question. Supersaturated, saturated, unsaturated with more than 1 answer possible. And you would have to know to check both. Does that make sense? Both. It's impossible to know which condition. So you have. Okay. All right. So for the next one. Maddie, we have a solution and we have 10 grams of salt hanging over it. And then after we stir in that salt, we have 14.2 grams in the bottom. What was the solution before we started?
Unsaturated.
You think it's unsaturated? So unsaturated means the amount of salt would go down. What happened?
Oh, it stayed like up.
So instead, it went from 10 to 14.2. So we found 4.2 grams that were not there to start with. How is that possible?
Oh, it's super saturated.
Yes, this is super saturated. So what happened here is that there was more salt dissolved than should have been allowed. Like there should not have been that 4.2 grams that fell out. That is extra salt that should not have been able to dissolve. But for whatever reason it was, whether they heated it up and cooled it back down or whatever, right? So that extra salt, as soon as we put this salt through, all 10 grams fell to the bottom, but because it disturbed the unstable stuff, just like the rock candy, those crystals formed on those salt pieces that fell out. It hitched a ride with the crowd moving through the hotel, right? So all the extras peeled out and left the solution as the salt fell through. So now at the end of it, what is that blue beaker? If the extra salt left, if only the extra salt left, what is that solution at the end? Jessica, I think I've called on you before, but it picked you again, so we're just gonna go with it.
It would be saturated.
It's perfectly saturated. All the extra was taken out and we're left with only how much should be booked. Scale of 1 to 10. Ask your questions. It's a weird concept. And Darshan, yes, on that second example, if there was salt left over instead of 0, we would have known it was saturated. We would have been able to put 1 answer. Good question. Okay. For this last one, Trisha, what is the beaker before we start if there's 10 grams left over? We add 10 grams and there's 10 grams in the bottom. What is the solution?
Is it saturated?
Yes, because 10 grams minus 10 grams is 0 grams, which means nothing dissolved. I can write words. I can't write words. Sometimes I can write words. Nothing dissolved. So that's saturated. Awesome. Faisal, at the end, what is it?
I think it stays saturated.
Yeah, because nothing dissolved, so therefore nothing changed. Love it. That's good. So I have a question about the third one. For 14.2, that is the 10 grams that we started with plus 4.2 grams that were extra dissolved in the water that should not have been there in the first place. So the 14.2 is the 10 we started with plus 4.2 extra, just to be clear where that 14.2 came from. Okay, so we're switching gears one more time. We're going to cover one more concept and it'll be brief. It'll only take about 5 minutes, but I want a scale of 1 to 10 right now on saturated, unsaturated, supersaturated. Okay, and you guys are being troopers. I know that we're going a little longer because we did that example in the beginning of net ionics, but I think that review is really important, especially after grading some labs. Okay. Last, do all substances have the same solubility? Ray, what do you think?
No.
Why not?
Because of like atomic size and like weight and all that stuff.
That was so pretty. Yes, that's a really great answer. So yes, first we know some things are insoluble and some things are soluble. So therefore solubility cannot be the same. But also when you're dissolving, everything that the water is holding will be held differently based on the molecule that's being dissolved, the size, the shape, the charge. Just like when you're booking rooms in a hotel, a single person traveling on business is not going to book the same way as a family of 4. Does that make sense? So the way and the type of room you need and how many rooms are available, like bigger rooms take up more space. So if you have bigger rooms in your hotel, you're gonna have less room to actually dissolve stuff, right? So you're gonna have less actual dissolved items in the same amount of space. So like magnesium sulfate is Mg2 plus SO4 2 minus. Not only is SO4 huge, but there's 2 positives and 2 negatives. Sodium chloride are 2 smaller molecules with single positive negatives. They're gonna have very different solubilities, okay? We look at these with the solubility chart because the other thing that depends on solubility is the temperature. And we talked about that a couple times unless in very rare occasions, cesium sulfate is an exception because it's very large. Notice how many things are there and how big they are. There are some exceptions, but in most cases, when we heat something up, more solute dissolves because of the faster moving molecule. So we have to know the temperature and how much we're dissolving. So to read this, I'm going to give you guys a couple examples and I'm going to ask you some questions. So Bob, you're up first. We're going to look at potassium chloride. So we're going to look at this line right here. Okay. What is the solubility of potassium chloride at 40 degrees Celsius?
Would it be about 40 grams per 100 grams of water?
Yes. So it'd be about 40 grams of KCl for every 100 grams of water. Okay. So once you get above 40 grams, it's not going to dissolve anymore. So on this line, would that be, if you added 40 grams of salt or of this salt at 40 degrees Celsius water, would it be saturated, unsaturated, or supersaturated?
Would it be saturated?
Yes, because it has a maximum capacity of 40 grams based on this chart at that temperature, and you dissolved the max capacity. Awesome. Gus, if I dissolved less than 40 grams, say I dissolved 20 grams at 40 degrees Celsius, what type of solution would I have then? Gus, are you there? Hello.
Hello, my bad. My thing wasn't unmuting. I don't know, semi-saturated.
So if it's semi-saturated, okay, not fully saturated, what's the word we use for that? What's the prefix? Why is it going sideways? I don't know why it's going sideways. There we go.
Semi-soluble.
Our 3 options are unsaturated, saturated, and supersaturated.
Oh, unsaturated. That would make sense.
There you go. It's unsaturated because we dissolved less than the maximum. Okay. If we somehow manipulated it where there was 70 grams dissolved at that temperature, it would be supersaturated because there'd be more than possible. So I'm going to ask a couple more just to see how you guys are tracking with it. So Akshar, back to you. Potassium chromate, that's the purple line. Okay. If I tried to, what would be the solubility at 80 degrees Celsius for the water? How many grams could dissolve?
About 60.
Yeah, so we'd have just under 60. So about 59 grams would dissolve because it's just under that 60 mark. Awesome. Next up, Sangeet. If I did sodium chloride at 90 degrees Celsius water, how much could dissolve? What's the solubility?
About 40 grams.
Yeah, so you go to the 90 degrees, you go up to the curve you're talking about, which is sodium chloride, and you go left and read where that is. And that gives me 40 grams of solute would dissolve for every 100 grams of water. So if I had 200 grams of water, I would dissolve 80 grams, etc. It's that ratio, 40 to 100, okay? So you guys see how dimensional analysis can be a thing here, and that's a precursor to next class. Shinmathi. Okay, Shinmathi. What if you did sodium nitrate? What is the solubility at 10 degrees Celsius?
Would be 80 grams per 100 grams of water.
It'd be 80. Yes. Now, last couple questions are gonna be about saturated, unsaturated, or supersaturated. So Darshan, I am gonna do 60 grams of NaCl at 50-degree water. So 50-degree water, 60 grams NaCl. Is that going to be saturated, unsaturated, or supersaturated if I'm successful?
That's above the line, so it's super saturated.
Yes, everything above the line is super, anything below the line is un, and everything on the line is saturated. So that is the idea. Next class, we're going to do a short, like 5-ish question Kahoot over this curve right here, reading this graph. Okay, that's going to be our warm up, our review. So be ready. After that, we're going to do the math associated with all the concepts we learned today. So last final scale of 1 to 10, how are we doing? I'm going to stop sharing for a second. I'm going to pull this up while you guys are giving me your 1 to 10s. Okay. All right. That is all I had today. And I'll let all of you have either emailed me about your missing assignments, whatever, so I don't need to hold anyone after for that. So you guys are good to go. You have a great day. Okay. If you have any questions, go to tutoring. Go to tutoring or email me if you have questions.
Have a great day, Miss Longley.
You too, guys. Bye.
Thank you.
Bye, guys.
Thank you.
So the 100 comes from the scale on the side, right? Where it says
Yeah,
solubility.
absolutely. It comes from the scale on the side, and it's always going to be 100. Like that's what they always use. But like on the test, they're going to say, okay, how much could dissolve in 300 grams? So you'd have to know to multiply that number by 3 kind of thing. So we're going to practice that next class. But yes, it's always going to be per 100, which means it's a ratio, which means we can do dimensional analysis. Yay. So that's where we're at. Okay.
And then to solve the questions, it's just like you go to the temperature, then you go to the gram value, and then
the correct compound.
The line. Sorry?
For the correct compound. Yes. You find the compound that's relevant. Yes.
Okay, and then if it's above the line, supersaturated, on the line, saturated, below the line, unsaturated.
Yes, sir.
Okay.
When you're saying like on the line or like what line are you referencing to?
Okay, so let me go back. Let me reshare. I was trying to get all the writing to go away. Hold on. And I'll share my screen again once I get there. Oh, you're gonna make me click through, jerk. Hold on. I pressed the wrong button. I'm the jerk in that situation because I pressed the wrong thing. Okay, so sharing screen. Okay, so on the line, so like potassium chloride is this line. Therefore, if I have a value that lands on that line for potassium chloride, it is perfectly saturated because that line indicates the maximum amount of what can dissolve at that temperature. For potassium nitrate, it's different because it's a different compound. You see, we could actually dissolve more at the same temperatures as we go up. So we're looking at the specific lines for each one. Does that make sense?
Okay. Yes.
Okay.
And would you rather, like, if I were to do QC 7.5 now, would there be stuff that we haven't learned yet?
Nope.
Or
We covered it all.
okay, thank
There,
you.
wait. 7.5 does it have math on it? Maybe.
Yeah, because I was wondering since you said we're doing that next class.
Yeah, maybe. I have to go back and look at. I think my brain just heard 7.4 and you said 7.5. There's math on 7.5. I'm so sorry. My brain was totally where you were.
No, that's okay.
Yeah.
Thank you.
No problem. All right. Any other questions?
Thanks, Ms. Longley. Have a good day.
Hi, guys.
When will you have tutoring? Like
I have
for the test?
Thursday after school, Friday morning, but you can also email me to schedule 1st and 8th period for your async days because I don't have 1st and 8th period. That's my planning period. So it's time that I can use to tutor as well if you need it.
Oh, okay. Thank you.
No problem.